In this video, we're going to continue our discussion about mathematical induction. So, i-discuss ulit natin principle and then yung use ng mathematical induction. So, let's review again sa mathematical induction. Una, i-verify muna natin if P sub 1 is true. And after that, saka tayo magpo-proceed, i-assume natin na P sub K is true and we have to show that P sub K plus 1 is also true to conclude that P sub n is true for all positive integers n. Okay, so let's have another examples. Okay, so prove that for any positive integer n and any real numbers a and b raised to n, quantity raised to n equals a raised to n, b raised to n. Okay, so again, verification muna tayo. Let n equals 1. Okay, so substitute lang natin sa equation. So, AB raised to 1 equals A raised to 1, B raised to 1. So, AB raised to 1 is AB, and A raised to 1 is A, B raised to 1 is B. So, as you can see, they are equal or they are identity. So, we can proceed to the next step. Okay, so for our next step, so i-assume natin, that AB raised to K for positive integer K equals A raised to K, B raised to K is true. Okay, for K element of N. And we have to show that AB raised to K plus 1 is equal to A raised to K plus 1, B raised to K plus 1 is also true. Okay, again for K element of set of natural numbers. Okay, so now, ang gawin natin, dito tayo gumalaw sa A raised to B K plus 1. Papakita natin yung right side. Okay? Now, yung AB raised to K plus 1. So, this is equal to AB raised to K multiplied by AB. Right? So, ito sa basic lang ng law of exponent. Okay. And then next, this is now, i-distribute lang natin itong AK sa law of exponent. No? So, this will be equal to A raised to K, B raised to K. Okay, so from our assumption, no? Kasi dito sa hypothesis natin, AB raised to K, this is equal to A raised to K, B raised to K. And then, we have here AB. And then, since multiplication yan, so pwede nating i-apply yung commutative. So, this is equal to A raised to K, A, B raised to K, B. So, pinagpalit lang natin itong B raised to K tsaka A. And then, the last one, pag multiply natin to A raised to K times A, that is A raised to K plus 1. And then, B raised to K times K, that is B raised to K plus 1. So, as you can see, napakita na natin, AB raised to K plus 1 is equal to A raised to K plus 1, B raised to K plus 1. Okay? So, doon, pwede na tayo mag-conclude that this is true for all natural numbers. Okay? Or for any positive integer n. Okay, next. Prove that for any positive integer n is less than 2 raised to n. Okay, so verification ulit tayo. So, verification. So, for our verification, ilalet ulit natin, let n is equal to 1, then 1 is less than 2 raised to 1. So 1 is less than 2, which is true. Okay, 1 is less than 2. So pwede tayo mag-proceed sa next step. Okay, so for our next step, assume that k is less than 2 raised to k is true for k element of set of natural numbers. And we have to show that k plus 1 is less than 2 raised to k plus 1 is also true for k element of set of natural numbers. Okay, so dito inequality yung approach natin. Okay? So, gamitin na natin to kaagad. Usually, no, sa ginawa natin sa previous examples, ito yung ginagalaw natin left, tapos pinapakita natin yung right, and then ina-apply pa rin natin yung ating hypothesis. Okay. Now, so dito, by the way, no, parang nakakalito siya. Iayos pala natin yung sulat natin. No? Nagkapantay. 2 raised to k. Ito naman, this is less than 2 raised to k plus 1. So, yan. Parang nagkapantay. Okay. Now, so gamitin natin tong assumption. So, kung k is less than, if k is less than 2 raised to k, then, pag nag-add tayo sa inequality ng 1, this will be k plus 1 less than 2 raised to k plus 1. So, hindi pa ito yung pinapakita natin na ang kailangan natin ipakita, k plus 1 is less than 2 raised to k plus 1 sa exponent. Okay? Now, since from our assumption or from our hypothesis dito, yung k natin ay element ng natural number. So, since k is element of natural number, or rather say k is greater than or equal to 1 kasi nga natural number siya, then we have 2 raised to k. This may be greater than or equal to 2. Okay? Kasi if it is 1, pwede maging 1 si k, then we have 2 raised to 1 equals sa 2 from our verification. And then, if it is greater than 1, then mas malaki itong 2 raised to k kay 2. Okay, and obviously, this is greater than also 1. Okay? Now, para saan ba yan? So, gagamitin natin siya kasi yung k plus 1, that will be mula dito sa ano natin, ito. This is less than 2 raised to k plus 1. We can say that since 2 raised to k is greater than 1, so masasabi din natin na ito ay less than 2 raised to k plus 2 raised to k. Okay? So, kung yung 1, papalitan natin to ng 2 raised to k, mas lalaki kasi yung 2 raised to k mas malaki sa 1. And this will be equal to 2 times 2 raised to k. So, take note dito sa alignment. So, k plus 1 is less than dito. And ito less than sa 2 raised to k plus 2 raised to k. But itong 2 raised to k plus 2 raised to k, this is equal dito. Okay? And then 2 times 2 raised to k, that is equal to 2 raised to k plus 1. And as you can see, ito yung gusto natin i-prove. K plus 1 is less than 2 raised to k plus 1. Okay? So that completes the proof. So pwede na nating i-conclude that n is less than 2 raised to n is true for any positive integer n. Okay, let's have this one. Prove that n squared plus n is divisible by 2 for any positive integer n. So let's try again. Verification. So for our verification, let n equals 1. Then 1 squared plus n is divisible by 2. 1 squared plus 1 is divisible by 2. 1 squared plus 1. And that is 2 is divisible by 2. Okay. So this is true. So we can proceed to our next step. So for our next step, assume k squared plus k is divisible by 2 for k element of set of natural numbers. And we have to show that k plus 1 quantity squared plus k plus 1 is also divisible by 2 for k element of set of natural numbers. Okay. Now, so since yung k squared plus k is divisible by 2, then may mag-e-exist. By the way, take note of this symbol. Ibig sabihin yan, there exists. So may mag-e-exist na integer m or natural number m. So let's make it integer to be sure. Okay. That such that k squared plus k is equal to 2m. Okay? So ibig sabihin lang yan, pinalitan lang natin yung k squared plus k to some even number. Okay, so this is an even number, that's why naglagay tayo ng 2. Okay, so ito kasi yung representation natin ng even number and sigurado tayo na itong 2m ay positive. Bakit? Yung k natin ay natural number. So yung square ng natural number at yung natural number din, pag pinag-add natin, that is also a natural number. Okay? So that will make 2m. Okay. So, pwede nating integer, so wala namang problema dyan. Or pwede nating i-limit sa positive integer lang. So wala rin problema dyan. Or let's make it natural number since yun naman yung para hindi na mabago yung symbol. So pwede rin natural number na kagad. No? Okay. Pero wala rin problema kung z yung ilalagay natin. So since set of natural numbers, subset lang din naman yung integer. Okay? So, anong ibig sabihin niyan? So, ibig sabihin niyan, thus, So ito kasi gagamitin natin ito mamaya, yung 2m na yan. We have k plus 1 squared plus k plus 1. Okay, o ba't tayo napunta dito? Dito papakita na natin na divisible by 2 na siya. Okay, so i-expand muna natin to k plus 1 squared. So magiging k squared plus 2k plus 1 plus k plus 1. Ngayon, ipalabas natin tong k squared plus k. Pagsamahin natin, itong k squared plus k. So, k squared plus k plus ano yung natira? 2k plus 2, no? Ilabas natin tong 2. So, we have k squared plus k plus 2k plus 1. Okay. So, yung k squared plus k, ano ba yan? 2m, no? So, 2m plus 2k plus 1. And this is 2 times the quantity or yan, m plus k plus 1. Factor out natin yung 2. And as you can see, m plus k plus 1 multiplied by 2, that shows na yung lumabas sa k plus 1 quantity squared plus k plus 1 is an even number. Because yung representation natin ng even number is 2 multiplied by any natural number or any integers. Okay? So, sigurado tayo na ito ay integer or natural number because m is a natural number, k is a natural number, and 1 is of course natural number. So, pag pinag-add natin yung mga natural numbers, that is a natural number. And since it is multiplied by 2, then it is an even number. Okay. So, yun yung gusto nating mapakita, no? This shows that, lagyan natin ang line na, k plus 1 squared plus k plus 1 is divisible by 2. Okay? So, since napakita na natin to na divisible by 2 for k element of natural numbers, we can now conclude that n squared plus n is divisible by 2 for any positive integer. Okay? And by the way, additional, ano ba ibig sabihin natin kapag divisible? Okay? Ibig sabihin kasi niya, kapag dinivide daw natin ito sa 2, wala dapat siyang remainder. Okay? So, kagaya ng pinakita natin dito, yung k plus 1 quantity square plus k plus 1 equal daw kay 2 times quantity m plus k plus 1. Pag dinivide natin sa 2 dyan, sa 2 yan, wala lang to. And wala tayong remainder. Ibig sabihin, kasi ang quotient natin will be m plus k plus 1. Okay? So, kaya natin nakita na divisible siya by 2. Okay? So, I think that's it. Okay, so that's all for mathematical induction.